So here we've established this function here as f of x, and we want to draw the inverse. Well, we don't have the equation to inverse, so we can't undo the equation, but we can take some coordinates and inverse those coordinates. Okay, so we're going to take these reference points, so -6, -3, -3, 3, 0, 3, 3, -3, and 6, +3. We're going to inverse those coordinates. So all the y's become x's. All the x's become y's. Okay, and when we draw this new inverse graph, -3, -6, 3, -3, okay, 3, 0, -3, +3, 3, and 6 up. Okay, so it's going to go, we're going to get a graph that looks like this. Now, the properties of inverses is going to be a reflection of that graph across that diagonal line. So I'm just going to show that. I'm just going to copy this. Okay, and we're going to take that same picture. Just going to grab that picture. Oops. And I'm going to overlay it on top of the other graph. And we should see that it is a nice inverse picture of that graph. Okay, so if I lay it on top of here, okay, well, it's going to be a graph that looks like that. There it is. And if we take a look at that picture, it is definitely a reflection across that diagonal line. Okay, so that blue graph and black graph are reflections of each other. So this idea of inverse of this reflection across this line, switching of x and y variables or coordinates, this idea of inverse, we also want to think of inverse as undoing a function. So if the function goes this way, the inverse is going to go this way through that function. So my output becomes my input. So notice that the same idea, if I switch my x and y's, my output and input, I'm going to be going in this direction through the function, and that is essentially the idea of an inverse. So how do I do inverse on tables? Okay, so if I start with g of -1, okay, well, that means that my output is -1, and the inverse is going to find the input. So basically, I'm going in this direction. Okay, so this works out to be f of, this is the same as f of the inverse of g inverse of 1, -1, is going to be +2. And then I can work out my f value from the table. Okay, so +2 maps onto 4. So the answer is 4. Okay, so we can do this one here. We start with A. Now we're going from A and we're taking the f. So we're going to map this way. So this becomes g inverse of the f of A is equal to b. So then what this means then is I'm starting with, this is the inverse of b, so that must be the output. So I'm starting with b and I want to go back towards the input. Okay, so that's going to give me the value of 4. Okay, so then try to understand how we map this on. F of A goes from x to f. Inverse b goes from the y to x. That gives me that. Okay, so f of 5, 2f of 5 means I first find 5 and I map it onto the A. So this becomes inverse of 2 times A. Okay, so what this means then again is the output is 2A and the inverse wants to find the input. So I've mapped my 5 onto A, and then my output 2A needs to map this way to give me the answer of A. Okay, so this is how we apply inverse on tables. So we've got inverse on tables, we've got inverse in a flowchart, we've got inverse in a graph, okay, and we've got the inverse idea as an undoing of a function or inverse function like x squared and x square root, plus and minus, times and divide. Okay, so these are some big idea concepts of inverse, and we can apply them in these ways.